Hello, my pre-calculus students. I am trying out a new app on my iPad. I have done a video with my calc kids. I'm trying a video with you guys now. And I'm going to try and go through parts of lesson 5.2 with you. So, proving trig identities is something I would much rather have you guys in front of me in class with, but we're going to give it a try and see what happens. I will say it would be to your advantage to still have available your lesson 5.1 notes that have all your identities and whatnot in them, because we're going to be using a lot of those same tricks to manipulate things, to change them from one form to another, to get them to equal what we want to. So lesson 5.2 is proving trigonometric identities. We're going to do a basic algebraic identity, and I say basic algebraic identity in that there's no trig involved in example 1. But the idea of proving, I don't know what you guys remember from geometry, excuse me. The idea of proving the algebraic identity is we are trying to get this left side here, so this piece right here, to in turn equal this right piece. So our job is to manipulate the left to make it equal the right. And so every time you see me do an identity, the first thing you're going to see is you're going to see me write out the left. And this is what I expect from you guys. So I'm going to write out the left here. That's x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1. And then what's going to happen is I'm going to come over here to the right of it and I'm going to work it. Okay, I'm going to work it out, and my goal is to manipulate it all the way down so that when I get to the end, I'm supposed to equal 2. So my job is to make this red stuff on the left equal this red 2 on the right. When you are doing a proof for me, what I'm grading is these middle pieces here. So, my job, what can I do to manipulate those two fractions? A couple of different ways we could go, depending on what you're already thinking. Technically, yes, we could go a common denominator. Getting a common denominator and multiplying these things by something to make a common denominator is actually going to be a little bit more work. We can actually get a common denominator using some simplifying techniques, or actually won't even be a common denominator in this one, actually, now that I think about it. So think about that x squared minus 1 on top. What do you guys know about x squared minus 1? And I would like to hope and think that you guys remember that can factor. And so x squared minus 1, if you recall, is a difference of two squares. It can factor into two parentheses. X squared breaks into x times x. The square root of 1 is 1, so 1 times 1. And then since it multiplies to be a negative, we use a plus and a minus. So my first fraction is x plus 1 times x minus 1 all over x minus 1. Then minus, and we're going to do the same type process for the second fraction. My second fraction already has a denominator of x plus 1. And again, my numerator is x squared minus 1. So again, to factor x squared minus 1, two parentheses, square root of x squared breaks into x times x. Square root of 1 is 1 times 1. Multiplying to be negative is a plus and a minus. Okay, so hopefully as you did that, you saw a little something happening along the way. And that is that we have some canceling that can happen. As we look at this, in my first fraction, x minus 1 can cancel with x minus 1. In my second fraction, x plus 1 can cancel with x plus 1. And so let's rewrite out what we have. The first fraction, those factors of x minus 1 cancel, and so I'm left with x plus 1. Minus my second fraction, the x plus 1's canceled. I'm left with the quantity x minus 1. At this point, obviously, some fractions cleared out real nicely. If we clean it up, you want to distribute that negative, and so I still have x plus 1, and becomes minus x plus 1. Do some cleanup. X minus x will cancel, and then we're left with 1 plus 1, which is 2. What was my goal? My goal was to equal 2. And so at that point, I have proven that this two fractions being subtracted on the left is equal to 2 on the right. And again, when I'm grading these, what I'm grading is How did you get from the beginning to the end? You already know the answer. The answer is 2. I'm grading the work, and that's what we have to work on. Okay, so let's look at example 2 here, which now we get to talk trig. And if we use the same idea as earlier, our goal is to start with the left, and you won't see me mess with the right at all. Our goal is to end at the right. So I'm going to do the same type process I did earlier, and I'm going to write out my left here, which is tan x plus cotangent x equals. And then this is where my work starts. My job that I'm hoping to get this to equal at the end, is secant x cosecant x. Sorry, technical difficulties, getting my pen to cooperate there. So, on the left, this is where I'm beginning. On the right, that's where I'm ending. My job is to fill in the middle now. So, thoughts of how we can manipulate tangent cotangent to equal secant cosecant. You can think back to those 5 items we had. Trying to come up with them off the top of my head. Take 2 fractions and add them together. Take a fraction, separate it. Pythagorean identities, factoring and foiling, and changing everything to sine and cosine. So I'm going to take tangent and cotangent and change them to sine and cosine. If we do that, we know tangent, according to our quotient identities, is sine x over cosine x, and then it's plus, and then cotangent, if you recall, is cosine x over sine x. As much as I would love to cancel, I know some of you out there want to cancel, we can't cancel because we're adding. So, since we're adding, take the 2 fractions and maybe turn them into 1. So what would be a common denominator if I already have a denominator of cosine x and a denominator of sine x? And so hopefully you realize that is just multiplying them together. So cosine x, gosh darn it, cosine x times sine x is cosine x sine x. On the first fraction, what is it we're missing here? We already have a denominator of cosine x. We need our denominator to be cosine sine, so we're going to multiply by sine x. If I multiply the denominator by sine x, I'm going to multiply my numerator by sine x. Sine x times sine x is sine squared x plus second fraction. This time I already have a denominator of sine x. Sine x times what gives me cosine sine, and that is multiplying by cosine x. If I multiply the denominator by cosine x, multiply my numerator by cosine x. So now cosine x times cosine x is going to be cosine squared x. Okay guys, do you see it? Hoping you see it. That numerator, your hint is there's squareds being added. Sine squared plus cosine squared is equal to 1 because it is a Pythagorean identity. I'm going to write pi over here as a reminder. It's Pythagorean identity. And so if that is 1 on top, I now have 1 over cosine x sine x. And this is where I sometimes, when I need to, I look ahead, look at where we're at, look at where we're supposed to end up, and you'll notice that cosine is in the denominator. It's the reciprocal of secant. Sine is in the denominator. It's the reciprocal of cosecant. And so we are at the point that 1 over cosine sine is equivalent to secant x cosecant x. And we have made it. Again, I'm hopeful you're seeing some of the connections being made and thinking about the other pieces we've done along the way. Okay, continuing along. I'm not sure if I'm going to do all 5 examples we have. My plan is 3 to 4 examples depending on where we end up. And one other thing to throw in, as I go through these, some of you may see other ways to get from one point to another point. That's not necessarily out of the option. As long as everything flows mathematically, then it will work and you'll get credit for it. If something doesn't flow mathematically, that's when you don't get the credit for it. Okay, I definitely have to work on my handwriting in this app. It's not the best, but I hope you're getting what you need out of it. It's hard trying to not touch the screen as I write. That's what I've got to work on. Okay, so moving along here. Example 3. Again, we are trying to prove that the left equals the right. So, as you recall, I'm going to start by writing the left down, which is 1 over secant x minus 1 plus 1 over secant x plus 1. And my job by the end is to somehow make this equal to cotangent x cosecant x in the end. So, let's get started. Thoughts on what we can do here? 2 fractions can come together as 1 fraction maybe, is what I would like you guys to think. So, as we're thinking about that, what would be your common denominator? I have these 2 binomials right now. Easiest thing is to make your common denominator the 2 pieces multiplied together. So my common denominator is going to be the secant x minus 1 times secant x plus 1. Okay, so go back here. My first fraction currently has the denominator secant x minus 1. We're going to need to multiply by secant x plus 1, which, what you do to the denominator, you do to the numerator. So I'm going to multiply by secant x plus 1. 1 times secant x plus 1 is secant x plus 1 plus second fraction. It currently has a denominator of secant x plus 1. To get to my common denominator, we're going to need to multiply by secant x minus 1. What I do to the numerator, or to the denominator, I do to the numerator. So I'm multiplying by secant x minus 1. 1 times secant x minus 1 is secant x minus 1. Okay. I'm going to clean up that numerator, of course. 1 secant x plus 1 secant x is 2 secant x. 1 minus 1 will cancel. Denominator. Okay, guys, this is one of those things we've talked about before. Do we multiply that denominator? Do we not multiply that denominator? And it's really one of those things that's hard to tell. I'm going to tell you in this situation, I am going to have us multiply the denominator. So how do we multiply secant x minus 1 times secant x plus 1? And hopefully you remember that means we need to FOIL. So if we FOIL, secant x times secant x is going to be secant squared x. When you do the outsides, secant x times 1 is secant x. When you do the insides, minus 1 times secant x is minus secant x. So since these are conjugates, remember they cancel. Minus 1 times positive 1 is a minus 1. Okay, again, following along here, check out the denominator. Secant squared x minus 1. Something you need to try and catch there. Hopefully you can see something here. Secant squared x minus 1. When I see squareds and 1s added and subtracted, I'm automatically going to check out my Pythagorean identities. I have a Pythagorean identity that says 1 plus tangent squared x is equal to secant squared x. If you notice, I wrote it off to the side there. Can that be manipulated to represent that denominator? And hopefully if you see that if we subtract 1 from both sides, we can manipulate this to read tangent squared x equals secant squared x minus 1. And so, with that denominator right there, secant squared x minus 1 can be replaced with tangent squared x. So, next line, I'm still going to carry down my 2 secant x. Secant squared x minus 1, I'm going to replace with tangent squared x. Okay, at this point, you kind of have to pause and think. I see the 2 that I need. I'm supposed to have secant x, tangent squared x, and I have I have secant tangent squared. I'm supposed to have cotangent cosecant. So, a couple of different ways to proceed. One option is that notice my my final answer is not a fraction. So how could I get this out of fraction? How do you take tangent squared out of the denominator? And if you do that, tangent squared in the denominator can be a cotangent squared out of the denominator. So one option I can do is I can rewrite this as 2 secant x times cotangent squared x is one option. Again, there's a couple of different ways I can proceed here. Remembering my goal is I need the 2, which I have. I need a cotangent, which I have. But then I also need a cosecant, which I don't exactly have. How do I want to do this with you guys? Okay, so 2 options. Take it and work with what you have. Separate the cotangent, and then I've got a cotangent and a secant I need to work with. Ultimately, I would say change things in terms of sine and cosine, and that's going to help you greatly here. So if I go ahead and change things, secant, if you recall, is 1 over cosine x. Cotangent squared is going to be cosine squared x over sine squared x. And again, it's all about manipulation at this point. The 2 is there. Notice top and bottom, a cosine can cancel. So if I cancel one of my cosines there, the cosine, the denominator, can cancel with a cosine on top. At this point, I still have the 2 out front. I have a cosine on top and 2 sines on bottom. So if I take those sines and split them up on top, I'm hopeful that you can see that a cosine x over a sine x, and then this other sign that I have, I can rewrite it as 1 over sine x. Again, all I've taken is what's left, which I had a cosine on top. I still have a cosine on top. I had 2 sines on bottom. I still have 2 sines on bottom. I just rewrote them. Because now what you can hopefully see is that there's the 2. Cosine x over sine x is cotangent x. And 1 over sine x is cosecant x. And so we get to what we need, which is what we're supposed to have. Okay. It's all manipulation. It's all a matter of figuring out where we want to be. I'm looking ahead to see if I want to, we're at about 20 minutes, trying to decide if I want to do one more example with you guys today. We'll go ahead and try one more example. I think I can move to my next page here, and hopefully that next page should be starting. I'll probably skip example 5, but let's go ahead and look at example 4, and then I'll talk about the homework real quick. So, if you recall, start with what you know, which we know that we are starting with cosine t over 1 minus sine t. My job in the end is to get this to equal 1 plus sine t over cosine t. I decided I kind of wanted to hit this one so I can make you guys look at it and notice it's already in cosines and sines. There's nothing to factor or FOIL. This is a situation where I want to talk conjugates. When I say I want to talk conjugates, think about what is the conjugate of that denominator, 1 minus sine t. And the conjugate of 1 minus sine t is 1 plus sine t. So what I'm choosing to do is I'm going to multiply my numerator and denominator by 1 plus sine t. And remember, as long as you multiply them by the same thing, that is legal. So my numerator right now is cosine times 1 plus sine t. I can write it as if I want as cosine times 1 plus sine t. I could also multiply it out. The denominator, and this is a big point of why we did this, when you multiply 1 minus sine t times 1 plus sine t. FOIL that for me. 1 times 1 is 1. The outsides and the insides will cancel, and my last part will be minus sine squared t. Okay, focus on that denominator, guys. Is there something I can do there? 1 minus sine squared t, can that be manipulated from something else? And I hope you are thinking Pythagorean identity. Sine squared plus cosine squared is equal to 1. And so, if we subtract the sine squared, we'll be able to get that to the point that cosine squared is equal to 1 minus sine squared. And if cosine squared is 1 minus sine squared, then that means in this denominator we can replace it with the Pythagorean identity. So instead of 1 minus sine squared, my new denominator is going to be cosine squared. I'm going to keep the numerator I had, cosine t times 1 plus sine t. Okay, guys. Look at where we're supposed to be in the end and where we're at right now. We are so close, if you've caught it. I'm supposed to have a 1 plus sine t on top. I have a 1 plus sine t. I also have an extra cosine t hanging out. I'm supposed to only have 1 cosine t on bottom, but I have 2. Do you see it? A cosine t in the numerator can cancel with a cosine t in the denominator. And that leaves me with 1 plus sine t over cosine t. And we've made it, okay? Our original matches our final answer. Again, remember I'm checking the work on these. For today, Wednesday, your job was just to watch this lesson. So you have officially completed your e-learning for today by watching this lesson and filling in the notes with me. Your job for tomorrow, Thursday, will be to complete the homework that goes with this lesson. I'm trying real hard not to overwhelm you guys. So the homework that you will have tomorrow that goes with this lesson is page 418, 12 through 39, multiples of 3. Meaning I am asking you to do 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. I will ask you to submit those on Schoology tomorrow, or sooner if you get it done, I suppose. And just, take a picture of it, submit it. I understand if there's some blanks here and there, okay? Give it a try, see what you guys can get done. Your next lesson then will be on Friday. So, email me with any questions and let me know how this video was for you. I'm hopeful I got rid of a stretching issue I had with my calc video, but other than that, I'm hopeful it was decent at least. So, good luck and let me know how things go.